For the maximizing and minimizing with trig functions problems and families of functions, what we'll do is just work through a couple of VCAA questions that really cover off a lot of the things that you'll need to know. So let's do an exam 1 problem first of all. The graphs of y equals cosine x, so this graph here, and the graph of a sine x, so we've got a dilation factor from the x-axis, so you know, sort of could go like this for one cycle. Scale not fantastic, and what we know is that they have a point of intersection at pi on 3, so they're going to collide at pi on 3 and probably somewhere else. So we want to find the value of a that makes this happen. So what we'll do is let them equal each other. Cosine x is the same as a sine x, where x equals pi on 3. So what we'll do is sub that in. So that's cosine pi on 3 is the same as a sine pi on 3. Alrighty, now the cosine of pi on 3 is a half, and the sine of pi on 3 is root 3 on 2. Alright, so we're going to multiply by 2, which gives us 1 equals root 3a. A is equal to 1 over root 3. Alrighty, so we know our function is y equals 1 over root 3 sine x. So if x is over that domain, find the x coordinate or the other point of intersection of the two graphs. So we know that one point of intersections is that, so we're looking for this other point of intersection wherever it is. Alrighty, so what we'll do is go cosine x is the same as a, which we know is 1 over root 3 sine x. Okay, so what we'll do here is I'm going to divide by cosine and multiply by root 3. So that's going to give me root 3 equals sine x over cosine x. Now sine on cos is tan, so we're solving tan x is equal to root 3, where x is an element from 0 to 2 pi. Alright, so when is tan root 3? So it's going to be at pi on 3, of course, we know that. So that's the first time tan is equal to root 3, and then it's going to be down here at 4 pi on 3. So we're going to say find the x coordinate, so it's only the x coordinate of the other point of intersection. So x is equal to 4 pi on 3. Alright, let's go to an exam 2 problem. I've got Mathematica locked and loaded here and ready to go. So I think the first thing we'll do is just define our function, which is t of t. T, already stuffed it. 25 plus 2 cosine pi times t over 8. Okay, let's have a look at it. Okay, all looks good there. Alright, so let's state the maximum temperature in the greenhouse and the values of T when this occurs. So we can see that the maximum temperature is going to be the amplitude plus the vertical translation. So it's going to be 27 degrees Celsius is the max when T is equal to. Alright, so when's it going to be 27 initially, and then again at the period? Okay, so when T is equal to 0 and T is equal to, so what's the period? The period of a standard cosine function is 2 pi over pi on 8 is equal to, what's that going to be? 16. So T is equal to 16. So they're the two times that it maximizes between 0 and 24. Now we could also run a solve for that if you didn't want to do it graphically. So solve t of t, and we know we're going to have to restrict the domain, so let's go to squiggly brackets, equals 27 0 less than or equal to t less than or equal to 24. Now I can put less than because I know it doesn't happen at, it does actually, so we better put equal, and just to be safe let's put equal. Close squiggly, solve for t. So t is 0, t is equal to 16. Okay, state the period of the function, so that's this one here, which is 16. So for 1 mark, don't need to show any working out. Find the smallest value of t for which t is 26. So it's going to be whatever this value is here. So let's just grab this solve here. And let it equal 26. And let's not let it repeat. So we'll get this, oh, it doesn't really matter, we'll just vet out the other one. So find the smallest value of t for which t is equal to 26. So what we'll do is go and say t of t equals 26, where t is an element. So where are we searching? Somewhere between 0 and what's half the period? 8. So I'm just choosing 8 as a value to search between because I know that that's going to be this one here. So you could choose 9 or 7 or whatever it is, but we know it's going to be somewhere here. And in fact, the answer is t is equal to 8 on 3. So there's your 2 marks, one for method and one for answer. For how many hours during the 24-hour time interval is t greater than? Right, so we know it's going to be greater than in this part here. Okay, it's going to be above in this part here, and then at 24, where's 24? So this is 20. So it's just going to be this part here. So what we're going to do is, so basically, let's sketch this and I'll show you what I mean. So we've got 27, 23, and 25. And what cosine does is it goes one repetition in 16. So up, down, down, up, up. Right, so it's going to be above there, and on either side of 16 it's going to be above, okay, as well. So I know that basically this part here represents 8 on 3 hours, or 2 2/3 of an hour, and this bit here is 2 lots of 8 on 3 by symmetry. Okay, so that's going to be 2 lots of the 8 on 3. Okay, now we know that it's 16, so that's 8, 16, 24. So what's going to happen is from here at 16, it's going to go back down again. All right, 24, what's the scale here? 25, 30. So here's 25 here. So we can see it doesn't go back above 26 until, after 25 hours anyway. So we're not going to worry about the third one. So let's do this. It's 8 on 3 plus 16 on 3, which is 24 on 3, which is 8 hours. Okay, so again, for 2 marks there, we've got method here and answer. Okay, Trig is designing a garden that is to be built on flat ground. So this is Trig's garden. In his initial plans, he draws the graph of y equals sine x and decides that the garden beds will have the shape of the shaded regions. He includes a garden path which is shown as line segment PC. Okay, so basically we've got the garden in here. So this is where the shrubs would be. Okay, in here, flowers, etc. And what they've got is a garden path going along here. The line through the points P, 2 pi and 3 is tangent at point P. Okay, so basically they're saying that this is a tangent. Okay. Find dy dx when x is equal to 2 pi and 3. Okay, so what they're getting us to do is find the instantaneous rate of change at this point here. So the way we'll do it is, what's Trig's function called? Y equals, so let's just call it fx. Oh my God. Equals, what is it? Just standard sine x. Capital S for Mathematica. All right, and we'll do f dash 2 times pi on 3. Negative a half. Probably could have done that. For 1 mark, so I don't need to show the derivative. It's just answer only. So we're going to go and just write negative a half. Okay, show that the value of c is that. Okay, so all right, so what we know is the gradient of this line m is equal to negative a half. We know it's got this value here, x, y, and we know it's got this coordinate here, x, y. So this is the only unknown value. So what we'll do with this one is we'll say that we know that there's a way of writing an equation of tangent, which is y take y1 equals m, x take x1. Now we know that m is negative a half. We know that one of the points was 2 pi on 3 comma and c comma. So it was 2 pi on 3 root 3 on 2. And this one was 0. So let's sub in what we have. So x, y, x, y. So it's going to be root 3 on 2, take away 0, so I'm just not going to write that, equals negative a half x, so which is 2 pi on 3, take away c. And basically what we want to do now is solve this thing for c. So what I'll do is expand this, which will chop that out. So we're going to have root 3 on 2 equals negative pi on 3 plus c on 2. Okay, I think that's right. Okay, now what we'll do is just throw that onto the left hand side. So we've got root 3 on 2 plus pi on 3. It's about to fall out. C on 2. Multiply by 2, which will chop out the 2's and that. So that's going to be C equals, better get rid of those little cancel marks there. So what we'll do is just go C equals, so this gets multiplied by 2, which gives us our root 3, plus this gets multiplied by 2, 2 pi on 3 as required. Okay, so there is what I was trying to show. All right. In further planning for the garden, Trig uses a transformation of the plane defined as a dilation of factor k from the x-axis and a dilation of factor m from the y-axis, where k and m are positive real numbers. Let x dash and p dash and c dash be the image under this transformation of the points x, p, and c respectively. Find the values of k and m if x dash p dash is 10. So this is the length of this line here and the length of this line here. So it needs to be 10 and it needs to be 30 respectively. All right. Okay, now I've been asked this question heaps and heaps of times here, and a lot of students actually don't really understand what this question was actually asking. So let's be real clear about how or what this is saying. Okay, So what we're going to do is find the value of k. This k, remember, is a dilation from the x-axis, and this m here is a dilation from the y-axis. Okay. Now what we want is x dash p dash, or line x dash p dash, to equal 10. Now let's go up and have a look at the diagram. Okay, and we can see that the original line xp has a height of root 3 on 2. That's its height at the moment. And what they want it to be is 10. Okay, so wherever 10 is, and it's not to scale, okay, that's what we want it to be. So currently it's root 3 on 2. We want it to be 10. So what we need to do is dilate it by a factor. Now what's that factor? Let's find out. So it's originally root 3 on 2. We want to dilate it by a factor k to equal 10. Okay, so what we'll do is multiply by 2, divide by root 3. That means k equals 20 on root 3. So that's going to be the dilation factor from the x-axis to move whatever the distance is, what root 3 on 2, to make it a distance of 10, i.e. that multiplied by this value will equal 10. Okay, now what we want to do is the same thing from the y-axis. So we want to dilate it by an amount. So we're going to multiply whatever this distance is by k to produce a distance of 30. So let's go have a look at what the point was. Alright, so that's the line xc, okay, and we know the distance of this because, actually we don't know the distance. What we do know is this distance here. We worked that out when we worked out the c value. Now our c value, or they gave it to us anyway, is root 3 plus 2 pi on 3. Pi on 3. So we know that this distance is root 3 plus 2 pi on 3. What we want to do is work out what this distance is. Okay, now how are we going to do that? Well, we already know that the distance from here to here is 2 pi on 3. That's the x value here. So all we're going to do is remove 2 pi on 3 from this distance, and we'll get the distance of this line here. Okay, so I know that that will be root 3 plus 2 pi on 3, take away this distance here, which is 2 pi on 3, leaving us with a distance, this line here must have, of just root 3. Alright, so let's go back down to what we were doing here. So we're going to take the distance, which is currently root 3, multiply it by some sort of factor, and we're going to get the answer to be 30. And the factor must be 30 over root 3. Alright, so that's our k value there. And it's not k, it's m. Alright, so I'd hate to do all of that work, only to find I got it wrong, because I wrote the wrong letter down. Okay, so it's m equals 30 on root 3. Okay, so if these are the transformations, the last part of the question says, what are the coordinates of point p dash after the transformation? So currently p, we've got it written down up here, that's point p. So currently it's 2 pi on 3 and root 3 on 2. And what we'll do is we'll dilate both of those by these factors here. Okay, so currently we've got 2 pi on 3, so this is point p, and root 3 on 2. So p dash will be 2 pi on 3. So we're dilating by so dilations from x change the y value. So what we've got is a y value currently of root 3 on 2. So we'll put a bit of space there, and we've got root 3 on 2. We're going to multiply that by, so which one's the from the x? K from the x. So this is going to be the one that we multiply by the y. So 20 over root 3. And this one here, 30 on root 3, is the one we multiply by the x, because this is the dilation from y. Whew, tough question this. That means p dash must be once 10 20 pi over root 3 and 10, which does make sense for sure, that the height is going to be 10. And this one here, well, we'll just have to rely on the algebra to kind of assume that that's right. All right, so there it is. Okay, so now you're ready to go on with, I think it was F was the last one I set there. So in theory now we've done 10B, C, D. Maybe it was E and F, I can't remember, but have a look at your announcement on Canvas and just make sure you're doing the right questions. There's also bucket loads of chapter review questions for you to brush up on Trig as a whole. Good luck.